All right, so on this page, once again, I'm going to write at the top SOHCAHTOA. Because you will use that regardless of what problem you're doing on this review. It's for the entire chapter. Sine, cosine, and tangent. Find the missing, it says, the directions say, find the missing sides, lengths, and or angle measures using the Pythagorean theorem, trigonometric functions, and inverse trigonometric functions. Be sure to show your setup and work for each problem. Round side lengths to the nearest tenth. So side lengths will be 1 decimal point, and then degree measures to the nearest whole degree. So that will be a whole number. Now, it's important to know when you use the Pythagorean theorem, when you use the trigonometric function, and when you use the inverse trigonometric function. So I'm going to make a little note right here so you remember when to use what. So Pythagorean theorem is only when you're given two sides. So if you have two sides, you can find the third side using the Pythagorean theorem. And you might want to write Pythagorean if you can't remember what PT stands for. So that's when we can use the Pythagorean theorem. Now, when you're finding I'm going to make another note on the left side. When you're finding missing sides, that's when you use your regular trigonometric function. So for missing sides, you're going to use cosine, sine, and tangent. But I'm going to use a different color so you know that when you're finding a missing angle, you're using the inverse. So it's important to differentiate between those two. When you're finding a missing side, that means you have the angle measurement. So you don't need to do the inverse trigonometric function. You're going to just use regular cosine, sine, and tangent. When you're trying to look for an angle, you have both sides given to you. So you're going to need to use the inverse function. Okay, so make sure you understand the difference between when you use the regular cosine, sine, tangent, and when you use the inverse of that. So let's look at number 12. So on number 12, we have x as a side, you have y as a side, and you have z, which is an angle. And we can use anything we want to solve. The easiest thing to do first is solving for the angle, because actually I don't have to use my inverse trigonometric functions. I can just simply subtract using my triangle sum theorem. So all three angles add up to 180 degrees, which means, these three angles right here add up to 180. If I take away the 90-degree angle, then I have 90 degrees left. So 36 plus z is 90 degrees. So you can simply just do 90 minus 36, and you're going to get z. So z is 54 degrees. Now, sometimes you will have to use the inverse functions, and in this case, we don't. Now, for x, you want to make sure that for x and for y, you're using 8 as a side, because that way it's more accurate. You don't want to use x and then use that to solve for y. You want to continue to use 8 in your ratio. So what I mean is when I solve for x, that's the opposite of the 36 degrees, and then the hypotenuse. So we've got opposite and h. So we're going to do sine of 36, because it's over here, equals x over 8. You can put that over 1, and then you can cross multiply. So 8 sine 36 equals x. You can also just simply multiply both sides by 8, but I'm using cross multiplication because you can use that whether the x is in the numerator or the x is in the denominator. You can always do that as long as you put your sine, cosine, or tangent over 1. So I plug that into the calculator, and I'm going to do the nearest tenth. And so you're plugging this into the calculator, 8 sine 36, and you're going to get 4.7. Now, I mentioned that you want to just use 8 in your ratio when you're solving for your variables. You don't want to use this 4.7 in a ratio because it's not as accurate as using the 8. So what I mean is I'm going to make sure that I use the hypotenuse when I'm solving for y. So I want adjacent over the hypotenuse. So that's going to be cosine of 36. And again, I put this over 1, cross multiply, 8 cosine of 36 equals y. And this is what I'm plugging into the calculator. And I will get 6.5 if I round to 1 decimal place. All right, for number 13, we have 2 missing angles. So you have y and you have x. So we will definitely have to use inverse functions for this one. But for the sides, we have 2 sides given, so we can actually use the Pythagorean theorem to find z. So let's start with finding z. I've got 4 squared plus z squared equals 8 squared. So 16 plus z squared equals 64. If I subtract 16 from both sides, I'm going to get 48. And then you would want to do a factor tree for that. And you end up with 4 root 3. And if I put that in the calculator, because I want to get a decimal for z, I'm going to get 6.9. Okay, now I'm going to go ahead and solve for x now. So for x, that's going to be my reference angle. And I want to use 4 and 8. So that's adjacent over the hypotenuse. So that's going to be cosine of x equals 4 over 8. And I want to use 4 and 8 instead of the 6.9 because that way it's more accurate. It's a whole number that was given to us. It's not an estimation. So then I'm going to take the inverse of both sides. And what happens is these two cancel out. And I'm left with x equals cosine of -1, 4 over 8. And this is what I will plug in to the calculator. Once you plug in cosine of -1 of 4 over 8, for x, you will get 60 degrees is an approximation because we want the nearest whole degree. And lastly, we're solving for y. So for y, I want to use 4 and 8 still. That's my reference angle up there. So that's opposite over hypotenuse. So sine of y equals 4 over 8. And then we take the inverse of both sides. These cancel out, and what you end up plugging in is y equals sine -1, 4 over 8. If you plug that into your calculator, sine -1 of 4 over 8, you are going to get about 30 degrees, which makes sense because, x and y are complementary. So it would equal 90 degrees together. All right, so for this one, I have 1 degree. So I have 1 degree given. Sorry, 1 angle given, 50 degrees. So I can find Z that way. I can just subtract. So 90 minus 50 equals 40. That's 40 degrees. And that's exact because we were given the 50 degrees and able to use that to find Z. All right, now for solving for Y, I want to, that's the hypotenuse because it's directly across from the 90 degrees. I'm going to go ahead and use 50. And what's adjacent to 50? I've got 5 is adjacent to 50. And then over the hypotenuse, so that's cosine. And I put this over 1, and I cross multiply. So y cosine of 50 equals 5. And then I divide cosine of 50 from both sides. So this is what you'll be plugging into your calculator, 5 divided by cosine of 50. And if you plug that into your calculator, you're going to get about 7.8 when you estimate that, when you round it up to 1 decimal place. Now let's go ahead and solve for x. So if I'm solving for x, I still want to use the 50 degrees just because that's what I was given. So opposite, x is opposite of that. And I want to use the 5 because that's a whole number and then it's not a decimal that we estimated. So if I have opposite over adjacent, that's going to be tangent of 50 equals x over 5. I put this over 1, cross multiply. 5 tangent of 50 equals x. And that's what I will plug into my calculator, this right here. And if you do that, you're going to get 6.0 when you round to 1 decimal place. For number 15, I'm given a reference angle of 64. So Z is easy to find. I'm just going to do 90 minus 64, and that's going to give me the other angle, 26 degrees. So Z is 26 degrees. And we've got to solve for x and y, which are sides. So if I solve for x, I want to make sure that I use the 10, and 10 is opposite of 64, and x is adjacent. So we're going to use tangent of 64 is opposite to over adjacent. Put this over 1, cross multiply. X tangent of 64 equals 10. Divide both sides by the tangent of 64. And this is what you'll be plugging into your calculator. 10 divided by tangent of 64. And you're going to round that to 1 decimal place. And so for x, you get 4.9. Now we have to solve for y. So again, I want to make sure I use 10 in my ratio so that it's a more accurate number. And I have 64. And y is the hypotenuse, so that's going to be in the denominator. 10 is going to be up top, so I've got opposite over 10 over the hypotenuse is y, so that's going to be sine. And then I'm going to put this over 1, cross multiply. Y sine 64 equals 10. Divide both sides by sine of 64. And this is what you'll plug into your calculator to get y. 10 divided by sine of 64. You round to one decimal place, and you're going to get 17.9. All right, for 16, I'm going to start with the angle B because that's the easiest. I've got 16 degrees that was given, and I can just subtract 90 minus 16, and that's going to give me angle B. So by doing that, you get 74, and that's what I'm going to start with. There's no particular one you have to start with. I like to start with the one that's the easiest one. All right, and I have 16 degrees. I need to find x. So x touches 16 degrees. That means it's adjacent. And 20 is the hypotenuse. So adjacent over hypotenuse is cosine of 16. And then I put this over 1, cross multiply. 20 cosine 16 equals x. And this is what I'll plug into my calculator. 20 cosine 16. And then I will round that to one decimal place, and you get 19.2. Now notice that when you're solving for y, that's directly across, that's opposite. So it's going to be opposite over hypotenuse, and that's sine. Put this over 1, cross multiply. 20 sine 16 equals y. I'll plug this into my calculator and round to one decimal place. So that is 5.5. Okay, last one, number 17. Again, I'm going to start with angle A just because that's the easiest. So 90 minus 37 will give me angle A, and that's 53 degrees. And then I'm going to go ahead and solve for x. So x is directly across from 37 degrees. That's the opposite. And I want to make sure I use 9. So 9 is adjacent. So that means I'm going to be using tangent. Because tangent, remember I haven't looked up here, but you're going to use this SOHCAHTOA to help you guide you with what you're going to use, whether it's sine, cosine, or tangent. So since I have my opposite O and I have my adjacent, that's why I use tangent. Okay, put this over 1, cross multiply. 9 tangent 37 equals x. This is what I plug into my calculator, and you will find that x is 6.8 if you round to one decimal place. And lastly, we have y to solve for. And again, I want to make sure that I use 9 because that's going to help me be more accurate in my answer. So 9 is adjacent to 37. Y is the hypotenuse. So cosine of 37 equals 9 over y. Put this over 1, cross multiply. Y cosine of 37 equals 9. Divide both sides by the cosine of 37. That's what you'll plug into your calculator. 9 divided by cosine of 37. And if you round to one decimal place, you will get 11.3.